Well, hello everyone, and thank you for attending today's webinar, Mahr's Product of the Month. And this month we're talking about the Millimess Dial Comparator. I'm George Schuetz, the Director of Precision Gauges of Mahr Incorporated, working out of Providence, Rhode Island. And if you have any questions during the presentation, use the chat feature and I will respond to your questions after the webinar by email. So let's begin. We got a few topics we're going to talk about today. We're just going to quickly go over the difference between measuring and gauging, a little bit about dial indicators versus dial comparators. Then we'll learn about the Millimess 1003 dial comparator, what it is, some of its features, why we might need it, a little bit of technical data, its applications, and why it's a great value as product of the month. So let's just take a quick look at the difference between measurement versus gauging, because this kind of ties into what dial comparators, especially the Millimess series, is great at. So measurement is the process of determining a dimension of a part by comparison to an internal standard. So we typically call these measuring instruments. Now, gauging is often used interchangeably, but it really has a slight and very significant difference. Gauging is the process of determining whether the dimension of a part is smaller or larger as compared to an external standard. So these are usually called comparative instruments or comparative gauges. Now, measuring instruments use the internal scale to measure the part compared to that internal scale. So when you think of a dial caliper or a micrometer, they have the scale or the internal standard as part of the unit. So they have the standard built in. They tend to be relatively slow to use and require a little bit more skill for accurate measurements. But on the other hand, they're very versatile and can be used to measure a wide range of dimensions. So, for incoming inspection or measuring a lot of different parts, calipers and micrometers are very strong for that. But they generally have some greater measurement uncertainties because they do require a lot of operator skill to use properly. Now, so these are typical basic measuring instruments. They all have the scale built in. So measuring hand tools include micrometers, calipers, and scales or rulers themselves. They have the lines marked on there, which is the internal standard. We also have some bench-mounted measuring instruments like height gauges or shop floor length machines, or even high-grade laboratory length measuring instruments. Now, again, you think about the laboratory measurements, but they can get some very good results, but they do take a little bit of time and expertise to get the right results out of. Now, gauging instruments are a little bit different. Gauging uses the process of determining whether the dimension of the part is smaller or larger as compared to an external standard. So comparative instruments like a bench ID/OD gauge here has an external standard. So you need a standard to set the gauge up. It has a lot of adjustable range to make a measurement, but the actual measuring range is relatively short. But these types of gauges tend to be a lot faster and probably more accurate than many of the hand tools that are measuring instruments. So these are more dedicated to the task. And of the gauging instruments, I think there's three types. I like to refer to them as fixed, variable, and fixed variable gauges, and just take a quick look at the difference between those. So a fixed gauge is basically a standard. This could be a go, no-go standard or a master ring of a specific size. It tells you whether that part that you have either smaller or larger than that standard. Doesn't give you any data about how much larger or how much smaller or whether it's good or bad. You just know that it's larger or smaller than the standard. So no information about part form, how big it is. It is probably the fastest qualifying way to tell whether a part is good or not. These masters tend to be only good for one size. So initially, the investment can be pretty low, but you do have to maintain them, certify them, and store them, which over years can add up. And you might require two masters for the size being checked. You want a min and a max go limit to qualify that part. Now, variable gauging instruments, they actually indicate how much the part deviates from the standard the gauge was set to. So they can provide actual data or actual deviations of the value. And from that, if you rotate the part or move the part actually, you might learn about the form, collecting the data, get some process trends, and maybe even help diagnose manufacturing issues. So I think these are fast and easy to use gauges. Like I said, they have a limited measuring range, but there's a lot of adjustable range. They can be a big investment at first, but from some of our gauges that have been around since the 50s and 60s, many of those gauges still function with good care and maintenance. And they only require one master to set the nominal size. And with that master, you can check the gauge periodically to see whether the gauge is drifting or there's some temperature issue going on with the setup. Now the next level up, the highest level, I think, is the fixed variable gauges. These are made to a specific size, like air gauging, fixed bore plugs, like Dimentron plugs. These are the most accurate, probably the easiest to use, and they still provide actual deviations. Also, because they're made to that specific size, they have the least operator influence. And if you explore the part, you can look for form, process trends, and collect data to get manufacturing or address manufacturing issues. So these are by far the fastest and easiest to use types of gauges. They have very limited measuring range, no adjustability. They're good for one specific size. So these are probably the most and largest initial investment, but again, they can last for decades when maintained. And there's only one master required to set the size. Now, these are typical comparative gauging instruments. They all have external standards. Portable ones could be snap gauges, portable ID/OD gauges, adjustable bore gauges, both fixed and variable. These are variable gauging. And you can also have bench-mounted comparators also, like ball comparators, gauge block comparators, or bench ID/OD comparators. And you can see all of these are gauges that have some type of short measuring range with a dial or digital indicator on them. So what's the difference between a dial indicator and a dial comparator? Let's take a look at indicators for a minute. They look kind of similar. They're analog devices. They also have a hand, maybe have tolerance limits. They have a stem where you can mount them by, and a sensitive plunger, which actually measures or senses the movement of the part. So dial indicators have been referred over the years as dial gauges, clocks, comparators, or just indicators. And basically they're useless by themselves. You must have a part or a gauge to mount these in to set up the measuring process. Most dial indicators have 2.5 revolutions of travel, but some have much, much more. And they come in a variety of sizes, ranges, and resolutions. usually determined by the part tolerance, where that gauge is being used, and what the gauge capability is. And some dial indicators may or may not have a revolution counter. So longer ranges were good with dial indicators when manufacturing process were not so automated. They allowed the operator to kind of creep up on the final size. Today, with today's high production rates and fast turnover, this can be a liability because when placing a part under the indicator, the hand tends to swing to its position very quickly. And sometimes it's tough for the user to see multiple revolutions of the hand pass by. So, an out of tolerance or a good part may look the same on the dial, even though the hand may have gone around 1 or 2 times. So a distracted or hurried user may not pick up on this error of the reading, and therefore there's a chance of one or multiple parts to be read incorrectly and passed on as good. Rev counters were added to help eliminate this issue, but some people don't pay attention to them or don't know how to use them, and reading errors can still happen. And dial indicators, like all analog devices, are burdened with the range resolution conflict. The higher resolution means you have to have shorter range. So digital indicators might help solve that problem because they have long range and high resolution, but you have to watch out for system accuracy versus resolution, that you're matching up the indicator performance to the application. So remember that with dial indicators, there is a range resolution conflict. Now we talk about dial comparators. Again, they look very similar, but there's a distinct difference. Comparators are short range indicators. They have a limited range of length of the dial, so the hand only is seen over the length of that dial. And they incorporate a dead zone for either under travel or over travel. Again, just like a dial indicator, they're useless by themselves. They have to be part of some other comparative measuring system. They can get very high resolutions because dial comparators are friction-free and have some very sensitive movements. So you can get a 20 millionth or a half micron resolution with some dial comparators. And some of these resolutions approach what a digital bench amplifier can do at a fraction of the cost. And some of them have a built-in fine adjustment to make zeroing easier, which is especially useful when the tolerances are tight and you have high resolution comparators. Again, comparators are burdened by the range resolution conflict. As with any analog device, higher resolutions meet shorter range. But in the case of dial comparators, I think this is an asset, and it's used for a tighter tolerance control. So it's very hard to read a comparative gauge incorrectly. It's either on scale and reading correctly, or it's off scale. There's no chance of misreads. And they also have built-in tolerance hands, which can help classify the part for the user, so they don't have to go counting grads to see whether that part is good or bad. Now, digital comparators come in short range travel with even higher resolutions, still at prices a lot less than bench amplifiers. So you can see how a dial comparator might be a great match for a comparative gauge. So comparators are short range indicators. Their limited range the range is limited by the length of the dial, and they incorporate that dead zone for over travel. So comparative gauges have a short measuring range, can be adjusted and set to different sizes. Therefore, comparative indicators I think, are the perfect match for a lot of these types of comparative gauges. So with a snap gauge, you can adjust the measuring capacity, but because of the short range of the gauge itself, a dial comparator is the perfect match for that. And since you can't read the indicator wrong, it's very easy for the operator to use and get the right results. So whether that be an adjustable bore gauge or a fixed plug gauge, a dial comparator such as the Millimess is the perfect match. Even in comparative stands, once the gauge is set to its specific size that's measuring, it's easy to find the correct deviation for that value. So you have a good range resolution selection. You find the right range for the part tolerance that you're using. Usually it's a quarter of the dial for the total range of the tolerance of the part. It's easy to read with little chance of reading error, and the tolerance hands can be used to help classify the part. So again, for a comparative stand, a dial comparator is a great, very value means of making high resolution measurements. Now, there's a whole family of Millimess dial comparators, both in inch and metric readouts. Resolutions going from 20 millionths to 5/10ths. We have versions that have built-in switches in them, which can help automate the process or turn a light on for an operator when the part is good or bad. We also have some long-range versions. They all look very similar, but the dial and the range of resolution is what is the difference. But today, our product of the month is the 1003 series. And of course, there's two versions of them. There's the metric system, which has a 1 micron resolution with a measuring range of 50 microns. And we have the inch version, which has a resolution of 50 millionths and a range of plus or minus 2 thousandths. So for many bench gauging applications, these are the perfect range resolutions needed for today's medium to tight tolerances. Now, what makes a Millimess dial comparator so good in terms of its measuring accuracy and repeatability? Well, we have a constant measuring force of the plunger. There's no spring change like you might see in a dial indicator. We have a retraction option for that. So if you want to move the part in there without touching the stem, this can be done. The stem is made out of hardened stainless steel for long life. We have a high precision Mahr ball guide bearing in there, which is very low friction, better than a sliding bearing, which provides higher repeatability. Because of that bearing design, there's very little chance of being worn from side loading. So you can put a part underneath that bearing and it's going to absorb that side load without wearing over time. We use a jeweled movement for maximum sensitivity and accuracy in conjunction with the precision gears and pinions that we use and the rotary stroke bearing. We have a self-contained movement, which is both quick and easy to remove or replace, and it's not affected by outside forces that might be applied to the case. We use clear, highly easy to read scale, and our comparators have the adjustable tolerance markets come standard. We also use a shockproof mechanism. There's a lever action here which engages the gear movement, so it's a following type movement. It follows the plunger as it moves up and down. but there's not a direct connection between the plunger and the following movement. So if the plunger gets a fast, sudden shock and moves up, the following movement will catch up to it, but will not be influenced by it. So and also on the opposite side, when the measuring range is exceeded, the movement stops even though the plunger may have gone further. So there's a clearance or a dead zone after the plunger stops moving, which does not affect the movement mechanism. So it's a very safe, highly shock absorbent dial comparator with great resolution, repeatability, and accuracy. There are different accessories for dial comparators. We have a lug back option. We have different contact points. We have sleeves to make an 8mm, a 375 is needed. We have a manual retraction that can be added on. So there's a number of different accessories, including a splash guard to help protect the comparator from splashes seen or most commonly seen out on the shop floor. All these things are available and easily added to the Millimess dial comparators. So in summary, the Millimess is a short-range, high-resolution dial comparator. It is perfect match for comparative type gauges, which include snap gauges, IDOD gauges, and bench stands. It's easy to read. Either the reading is on scale or it's not. There's no chance of the dial indicator being misread. Millimess comparators with their ball bushing design, stainless steel components, shockproof movement are designed for the shop floor. And all these features help to assure very high performance. So I think it's a low cost, high performance comparator for everyday use and really should be a natural choice for a lot of dial indicator applications or potentially for as tolerances change, the tolerance get tighter, you need shorter range, you need higher resolution. Switching to a dial comparator might be a great step in improving the measurement results. And it's the Mahr product of the month, which means it's great added value. So it's the August product of the month. You have both 1003 series Millimess comparators at a special price. And if you order the comparator this month, you'll get the Mahr mug to enjoy as you use the dial comparator. So why choose Mahr? I mean, the Millimess is a great product, but the people at Mahr, we have a broad product range for industrial metrology. We have lots of technical application competence to help support you. Our products are all designed for high performance shop floor use. With promotions such as the product of the month, we offer great prices and high quality, helping you achieve the best value. So after this webinar, we're going to send you a link to the recording of this webinar and follow up again with the PDF of the product of the month, the Millimess 1003 series dial comparator. So thank you for your attention today. Thank you for learning about the difference between comparators and measuring gauges, the difference between dial indicators and comparators. And it's been a lot of fun talking to you today. Have a great day.